Okay. All right. So I got the recorder up and running. I just want to make sure that it is from the right channel. I think it is. Okay. So I'm pretty sure it's recording just fine. All right. So I am going to minimize OBS because I'm not streaming from OBS. It can go away for the most part. All right. So what we're going to do today, I'm going through the announcements first, just to go over a few items from the announcements. I'm hoping people are reading what I post in the announcements because that's actually pretty important stuff. The first one is we are going to go back and take a look at exam one today. I hope you guys all had a chance to kind of at least read through the questions and kind of put some thoughts into it. You may not be able to solve every single one, but it should give you an idea of how ready you are for the exam. Okay. So that's one. The exam policy and preparation guide. There are two links. The first one is mandatory. I would assume everybody to have read the first link by the time we have the actual exam, which is 1 week from today. The second one is not mandatory. Let me just go there and talk about which one. So the exam policy is mandatory. I would assume everybody to have read it before the exam. I did make some changes today, minor changes, but I can point out where the changes are. But this one is optional. Exam preparation guide. It's just based on my own experience as a college student a long time ago. What I could summarize, that can help you. But everybody is different, so the way you study may not be the same as the way that I study. The way you want to kind of condense the notes into just a few pages may not be the same way that I would do it. So that's entirely up to you. I'm just going to tell you, what I would have done if I were to take an exam today or next week. So there's that. The lecture recording distribution is now different because I am not live streaming because of the unreliable Wi-Fi connection. I don't know what is going on. I don't think it's the actual Wi-Fi signal itself that is a problem. I think it's how they set up the router or how the router goes all the way back to the actual network that is the issue. But I do get drop connections occasionally. I would still have an actual Wi-Fi connection. The icon still reports that I have signal, but it would have lost actual connection to the internet. So so that's why I'm actually recording the lecture on my local hard drive, and then I would upload the content to YouTube after a class. All right, so now we are moving on to this slide here. It has a one single link, which is this one. This is based on some research that I did over the weekend. There is a way to integrate all the Canvas activities, which include the homework assignments and whatnot, from all of your classes into your Google Calendar. So if you put your other appointments and whatnot into Google Calendar, this may not be a bad idea because now you have one consolidated place where you can just take a look and okay, I got assignments due today and tomorrow from these classes and so on. And it's live, which means you only have to do this once. Once you do this, then any changes on the Canvas side is going to feed to your Google Calendar, which I think is kind of really useful because the exam date of this class is on Google Calendar. This is how I keep track of things that I need to track. In the same document, I also talked about how to use a notification reminder, which makes notifications on your cell phone quote unquote sticky. In other words, you cannot ignore that, which I'm very good at. Okay, I can ignore notifications. When those one-shot things, it's like, yeah, I'll get back to it later, and later is like never. But you can make it sticky, which means a un a unprocessed notification on your phone will keep beeping you every 3, 5, 15 minutes. It is programmable. You can also go to the notification itself. It gives you a little bell, icon where you can click on, and then you can say, okay, remind me in an hour, because you might be working on an assignment where you're getting a notification for, and you go like, okay, but I'm still working on it, so don't beep me for another hour so I can focus. So that gives you a lot of options in terms of how you can track what you need to do, and also make it do not nag you as much, and and so on. All right, with all of that said, we are going to go to exam one. This is exam one from spring 2022, which means this is actual. Okay, this is not a practice test whatsoever. This is the actual exam from spring 2022. So you can read about the instructions. The instructions may not be the same because for this class it is going to be on paper. So this is going to be in person only and on paper only. If you have been taking notes using your iPad, you will probably want to be able to print it out because you won't be able to use the actual iPad during the exam. So you have to print it out. You can bring anything that is either handwritten or printed prior to the test. So if you look at all the modules and you say, okay, I think this might be useful, print them out, bring it with you. My suggestion, if you read the exam preparation guide, my recommendation is to create your condensed version of the notes for this class because the whole process to create a condensed version is studying already. That is at least one pass through all the material that I have taught in this class up to this point. Two, because your condensed note is your creation, so you should probably know where things are. Okay, I need to find the definition of blah. Okay, I know it's over there because I just put it there within a week of time. Or I want to know, how to apply multi-digit addition. I know it's over here because I put it there within a week of the exam. So from that perspective, your own condensed note is going to be a lot more helpful than printing my material. Okay. Now, not that you cannot do that, but I think your own note is going to be a lot more helpful. You can use post-its, you can use other things to help you, quickly identify which section of the note is about what. Okay, so anything that is either handwritten or printed prior to the test is fine. Do we have any questions about what you can bring to the class? No questions? Okay. All right. So with that said, we are going to move on to talk about the first three questions have the same nature, but they are of different difficulty level. So I'm going to start with question number. Which one do you guys want to start with? Do you want to start with the most difficult one or the easiest one?
I mean, sequentially, we'll work fine.
Okay, so we got one sequential. Go ahead.
Yeah, just go in order. Start with
In order? Okay, we can do it in order. All right, so I am going to do this in order. And the way I'm going to do this is I can take a screenshot here and paste it into Zerno. So this way, I can just use handwriting for the rest of this discussion. All right. Something. Oh, here we go. All right. So I can now do a paste on this side. And of course, you guys cannot see Zerno because I have not switched to Zerno. Okay, there we go. All right, so this is the question, and we need to resolve, all of the question marks. So first of all, how do we read this part of the question? The top row, 0, 1, 2, and 3, right here, 0, 1, 2, 3, those are just the bit positions, okay? So I just make it very clear where is bit 0, where is bit 1, bit 2, and bit 3. Okay, so it doesn't convey anything else other than the bit positions. X, Y, Q, T, D. I really hope by now they are familiar. Okay, because they are the various bits that we need to use when we are performing multi-bit subtraction. And we have used those symbols already, not only in base 2 subtraction, but also in base 10 subtraction, which is how I started the base 10, the base 2 subtraction module. Started off with base 10, and this is just the structure of how we perform subtraction. Are we still good so far? All right. All right, so now the first thing, to answer any question, not only for CISP 310 and for this class and only for this particular exam, But with almost every single test that has an open format, the first thing you probably want to do is to remember, okay, what kind of material that we have studied in class is relevant to this question. So in this case, there are 5 specific rules. So I'm going to give you the five specific rules, and I'll give each one a label because this way you can just refer to the label later on in your answer instead of writing the entire rule out, which is time consuming. So A is going to say, how do we compute Q of I? Okay, so in binary subtraction, how do we compute Q of I? Because x and y are given to you, so there's no need to compute x, y, but we do need to figure out how to compute q of I because it is not given to you. So what is q of I in binary subtraction?
The remainder of x and y.
It's r of x and y. It's the single digit difference when you subtract y from x.
Modulus of.
It involves the modular thing, right? Right. Okay. So r, it is r of xi yi, which is globally defined as xi plus 10, the whole thing, minus y, and then the entire thing, mod with whatever base we're dealing with, but this time it is in base 2. That is how R is going to be defined for any base. In this case, we have 2 because we're doing all the calculations in base 2. That's not what we're going to use because remember, we can now use binary operators. So we basically change this to xi exclusive or yi. There's nothing new here, okay? I have to emphasize there's nothing new here. All of this stuff here is supposed to be knowledge that you can glean, that you can basically extract out of the modules and out of the discussion in the lectures. So there's absolutely nothing new, okay? I have not added anything on top of what has been discussed already, which means for anyone who's looking at this and go like, I have no idea what that is, there's a that's a sign that those people may need to study, like seriously study. You still got a week before the exam, so there's still time, but this is an indicator. All right, so that's one. Let's look at the rule B. I'm going to use, okay, there's no Z because we are talking about subtraction. So there's D of I. D of I is R of QITI, which then in return is, I'm just going to take the shortcut here because we already know R is expressed as an exclusive OR, but this time it is between the QI and the TI. So once again, nothing new. We have talked about this in class already. Rule C is about how we compute the borrow bits, okay, the T bits. So now we say T of I plus 1 is B of xi yi or B of qi ti. And now we have to say, okay, but what is the borrow function? The borrow function is if x is less, if xi, okay, B of xi yi is saying if xi is less than yi, return a 1, otherwise return a 0. That is how the borrow function is defined regardless of the base. However, we look at the borrow function in base 2 and go like, I think we can use binary operations to do all that stuff because that's the whole idea. We want to use binary operations or logical operations. So this way everything can be done with logic gates. And we know all the logic gates can be done, can be implemented using transistors. So that's kind of the idea. So now we can say this is the negation of xi and yi, or the negation of qi and ti. So once again, I have not introduced anything new whatsoever. Okay, this is nothing new. So all of this stuff, has been discussed already in class as well as in the module. If there's anyone, I'm not saying that there is anyone, but I'm saying if there's anyone who has not really read through the modules, really carefully and try to extract all the definitions and try to understand the rationale, you got a week to do it, okay? Because not doing that is not going to end well, in exam number one. All right, so we have two more to go. The other two has to do with the overflow and the L flag. So we will start with the overflow flag, which is uppercase O, but it is denoted using a lowercase o over here, just so it doesn't look like a zero. So the overflow is, we can start with x subscript m minus 1 and the negation of y subscript m minus 1 and the negation of d subscript m minus 1, where m is telling us what is the width of x and y. So I'm going to make it clear here. M is the width, the bit width of x and y, or the negation of x subscript m minus 1 and ym minus 1 and dm minus 1. Okay? Once again, this is nothing new. Okay? This is stuff that we have done already in one of the labs. Okay? After the lecture. So I'm writing all of this stuff out here just so that we can refer to the rules A, B, C, D, E as we try to solve the individual bits. All right, there's one more, which is E. So E is the L flag, which is defined to be the sign flag exclusive OR with the O flag. Oh, so that means we need, well, okay, we don't really need it. We just have to remember that the sign flag is the most significant bit of the difference. So it really is the same thing as D subscript M minus 1. All right. So that's the first step, which is basically remembering what knowledge that we have learned in this class relates to this question. Okay, now, what is the next step? The next step is to look at what the zeros and ones are given, which ones are given to you, and then you ask the question, how do I use the known bits in order to solve for the unknown bits? In other words, you're trying to say, we know the L flag, right? So we know, this L flag here has to be a 1, which means the sign flag and the overflow flag have to be different. Because the only way to make exclusive OR a 1 is to have one side being a 1, the other side being a 0, or you can switch, okay? But you basically need the two sides of the exclusive OR to be different for the exclusive OR to be a 1. Okay, so that may be helpful, okay? So if we might be able to use rule E. So if I use rule E, I still have a problem here because I cannot tell, which one is supposed to be a 1 and which one is supposed to be a 0. Well, that can happen, okay? So what do you do in those situations where you can say, well, I know it has to be in one particular way, I just cannot tell which way. So what are you going to do?
Could you write down both possibilities?
Exactly. You explore the what ifs. So to those people who are thinking, oh man, that's going to suck because there are so many different possibilities, the answer is no, because this is all binary, right? If it's not a 0, it has to be a 1. So at the most, you have two possibilities if you are just looking at one thing and go like, well, I'm not really sure whether that's supposed to be a 0 or a 1. You can play it out, which is what I'm going to do. Okay, so I'm going to play it out, and I'm going to write down, how I am going to play it out. So I would say L is 1 because that is given to us. And based on that, and also the rule E, this implies one of two things has to be true. So one thing is we have overflow being a 0, and then D subscript M minus 1. Well, okay, I'm just going to make it more specific because now we know we already know the number of bits. So D2 is going to be a 1. Or we can be the other way, which is overflow is a 1, and the most significant bit, or also known as the sign bit of D, is a 0. So we can even say or So this way we know, okay, it's one or the other. Are we doing okay so far? So we know it has to be one of these, okay? Because with these questions, each question mark can only be a 1 or a 0, but it has to be 1 or 0. There's no such place in the entire puzzle where a question mark can be one or the other. It has to be, it's deterministic, okay? All right, so now we look at these two possibilities, and then we ask, what is this going to imply, okay? In other words, if I just, for the time being, say that overflow is 0 and D2 is a 1, what is the result of that? Well, there's not a whole lot you can say. In other words, there are a few scenarios where overflow is going to be a 0 and D2 is a 1 over here. You can rule out just one single possibility, but otherwise you cannot really um, do much about it. Okay. Well, actually, we can go for this implication and see how far we can push it. So if overflow is a 0 and we know D2 is a 1, what can you say about um, x and y, y2, x2, and y2? So based on overflow, how overflow is defined here, and based on we make the assumption that D2 is a 1, what can you conclude about x1, x2, y2?
Are they ones as well?
Hmm?
Are they ones as well?
Well, we can rule out one possibility because between x2 and y2, there's only one configuration in combination with d2 equals to 1 that can make it overflow, right? And we know it's not overflowing, so we know, okay, one thing is we know that it is not the case that x2 equals to 0
Oh,
and y2 equals to 1. Because that, if x2 is a 0, y2 is a 1, combined with the assumption that d2 is a 1, then overflow is going to be a 1. But we are already making the assumption that overflow is a 0, so it cannot be this case. But there are three other cases, right? So that takes even more exploration. I think I'm just going to pause on that particular branch and look into the other one. Okay, let's see what it can, tell me about, the bits. Okay, so in this one, it is saying let's assume overflow is a 1 and D2 is a 0. This one is a lot more informed because by knowing overflow is a 1 and D2 is a 0, it just helped me lock down the values of D2 as well as Y2. What do you think this is going to imply in terms of what X2 has to be and what Y2 has to be? What do you think? Just looking at the overflow equation, we know, okay, based on this assumption, we know this is a 1. So that means one of these two has to be a 1 as well. But we also make the assumption that D2 is a 0. So if D2 is a 0, this expression has to be a 0, which is not going to be helpful. But this one can still be a 1 because this is taking the negation of D2 first. So now we are locking down that Y2 also has to be a 0, X2 has to be a 1. So we'll plug that in and see if it works. So X2 is a 1, Y2 is a 0. Okay. And then we say, okay, can we make this happen? So we now say that further implies, okay, what is going to be Q in this case? So using which rule we can figure out Q of I? Or Q2 in this case?
um, the A rule, right?
Yep, we are using A rule. And this is one way to do it, is to utilize A rule. We can now say it implies everything that we have assumed up to this point is going to imply that Q2 is, well, what do you think? Okay. According to rule A, Q2 is the exclusive OR between X2, Y2. What are the current assumptions about X2, Y2?
That X2 is 1 and Y2 is 0.
Yep, so what is one exclusive OR with 0? 1. Very good. Okay, so now this it says here Q2 is a 1. Okay, so knowing Q2 is a 1 and knowing that T2 is a 0, this will further, okay, I'm going to have to wrap this around and say, what do we know about D2 other than the assumption? So using rule B, what can we say about D2? So rule B says D2 is the exclusive OR between Q2, T2. T2 is given to you. It is a 0. That one is not up for negotiation. Okay, there's no negotiation whatsoever. But we also know that Q2 is a 1 based on all the assumptions leading up to this point. So what do you think is D2 based on the rule of B? Okay, look at rule B, right? We're trying to figure out what is D2, but we already know based on the assumptions what Q2 is. What is Q2 again?
1.
Q2 is 1. What is T2, which is given to you already from the question itself? It's a 0. 1 exclusive over 0 is 1. Okay. Don't you think we have a problem here? What is the problem? It's a
Because
contradiction.
D2 is 1, would that make the overflow false?
Nope. It's a problem because we are making the assumption that overflow is a 1 and D2 is a 0. So we go like, okay, that is not working. So at this point, you can say it leads to a contradiction. Okay, so if you don't want to say lead to a contradiction, which takes a little bit of time to write, you can say, just draw a skull. That doesn't take nearly as long. You can make a little stamp, you bring a stamp with a skull on it and go, this is not working out.
Could you, because we went down this path and we know either or.
Yep.
That
So it
means
has to
we
be the
would
other
eliminate
path.
The other one.
Yep.
Automatically. So we can use that in our answer.
Well, yes. So at this point, what you can conclude is the other branch. Okay, let me point out which branch we're talking about. So now you know this branch has to be the right branch because we already know L is a 1, which means overflow and the sign of the difference have to be different. But if we say, okay, there are 2 ways they can be different. One is overflow is a 1, and then the sign bit is a 0. The other one is exactly the opposite way. But we already know this way is not working out. So it has to be the other way. Okay, so now we basically have to continue with this particular line of reasoning.
Oh, so you still have to explain that side. I thought it was
Yeah,
automatically.
well, I mean, you can make a conclusion about the overflow and the sign bit at this point.
Yeah.
So we can actually go ahead and modify and add that as part of the answer. So let me do just that. So the eraser actually has as an option of using a whiteout instead of an eraser, which is handy in this case because in this case I can now erase overflow. Oh, okay. I'm still using the wrong tool because I forgot to press my button. So we can now get rid of this because we know what that is supposed to be, and we can get rid of that because we also know what that is supposed to be. So based on this, we know overflow has to be a 0, and we also know that the sign bit of the difference has to be a 1. So we have resolved those 2 bits. So now the question is, okay, so what do we do to figure out the rest of the bits? As it turns out, it's not hard, okay? Because what you do, you should say, we already have a conclusion that D2 has to be a 2, has to be a 1, sorry. And T2 is known to be a 0 from the get-go. That's not even up for negotiation. So what rule are we going to use to deduce what Q2 is supposed to be? Well, okay, first of all, how do you know which rule out of A, B, C, D, E that you need to use in order to figure out what Q2 is supposed to be? Yes?
B.
And why would you use B?
Because it explains what makes B2 in this case.
It relates the bits, right? So if you look at rule B, we already know what is TI, right? That's known already. We already know what is DI, that's known already. So we only have one single unknown in a single equation. Now I know this is not regular algebra, but what you learn from regular algebra of having an equality and you have only one unknown, it's usually solvable, it works here as well.
You can move the signs, is what you're saying? Like you can, in a sense, D1 is, equal to Q of I plus T of I. Could you say Q of I is, or negative Q of I is equal to negative V of
Okay,
I?
so the way I would reason this out in my head is to say something exclusive or with zero ends up with a one. So the question is, what can exclusive or with a zero and end up with a one?
One.
It has to be a one. So now I say, okay, so now we have a conclusion that Q2 also has to be a one. Is that okay? So I'm going to use my little tool here, go back to the question and say, yep, we know what this one is supposed to be now. It is supposed to be a one. Okay, so now we look at this and go like, but what else are we going to do at this point? In other words, that leaves us two possibilities, because in order for Q2 to be a one, we only know that x2 and y2 are different based on rule A, right? Because rule A says here Q of I is the exclusive or between xi and yi. So the two reasons, okay, I shouldn't say only, the two reasons why Q2 is a 1 is x2 and y2 are different. But there are two ways that they can be different. Because we can say, oh, okay, but x2 being a 1, y2 being a 0 is one way, x2 being a 0, y2 being a 1 is the other way. They go like, but how do we know which way is which way? So this is where you can just kind of sort of plug it in and see which one does not work out, right? So we can now say, okay, um, we have to combine the rule of D and say, you know what? D is going to help us out in this case. Because we already know that D2 is a 1 already, and we also know overflow is a 0. So it's ruling out one possibility. Which one is it ruling out? Okay, so we know overflow is a 0, okay, which means the two conjunctions in overflow, they both have to be zeros, right? But we also know that D2 is a 1, so we know this D2 is a 1. We also know this particular D2 is a 1. So this side is done for already. Because D2 is a 1 and it's negated in this conjunction, which means we already have a 0 in this entire conjunction on the left-hand side of the OR. So it's not a concern for us, okay? It is already automatically 0, not a concern. But the other one is a concern, because the other one has a non-negated D2, which is a 1, which means if I choose x2 and y2 incorrectly, I can still end up with a 1 with this entire conjunction. So if I choose incorrectly, okay, to make it a 1, x2 is a 0, y2 is a 1. So we know we can rule out x2 being a 0, y2 being a 1, which is left with us with only one possibility, which is x2 is a 1, y2 is a 0. So now we have that conclusion, and that is x2 is a, okay, I did all the reasoning, but I cannot remember. I think that's a 1, and then y2 is a 0. So now I can go back and backfill those two, right? So I can say, we know what that is, and we know what that is. Oh, there we go. And we know this has to be a 0. And this one, oops, nope, the other way around. This one has to be 1. That one has to be a 0. Woohoo! I would say this is probably the hardest part of this entire question, because every line, every single step of the reasoning is a little bit tricky, because you have to kind of go backwards a little bit. Given this, what can we say about the other bits, right? Okay, so given what we know now, in this case, can we just go ahead and solve for T3 right now? I mean, just so that it doesn't hang around like that?
Yeah.
Absolutely, right? Because everything that we need to figure out T3 is already known, because the entire digit 2 column is already known. So we have 1 minus 0, which doesn't end with a borrow, and we have 1 minus 0, which also does not end with a borrow. So we don't have any borrow from the third digit, or digit 3. So now we can say, okay, so we know T3 is going to be a 0 in this case. Okay, I erased a little bit too much because I did not intend to erase the negation. All right, so now we know this one is a 0, but we have to say why we know it is not a 0, right? Yep. So I think my voice is still getting recorded. Just have to turn off my Spotify, which somehow got turned on by itself. Pause. There we go. It's basically playing my sleep music, and that's the last thing I want all of you or myself to do. We don't want to sleep right now. Wrong time to do that. Okay, so now we can go back to, oh, I can probably hide my OBS on this side. Okay, so now we can say, C now has everything that we know that to deduce that T3 is a 0, not a 1, 0. There we go. Whew. Okay, so now what do we do to figure out the rest? The rest turns out to be actually pretty easy. Okay, you look at this and go like, no, it cannot be easy. But I can tell you it is easy. So we look at column 1 and we ask, holy smokes, column 1 only has one single 1, which is given to you as y1 being a 1. How do we resolve the other 1, 2, 3, 4? 1, 2, 3, 4. Yeah, the other 4 bits of column 1. Well, it's not alone, because the borrow bit that we know as T2 is really helpful. Because we already know at this point that T2 is a 0, right? So knowing T2 is a 0, okay, just knowing that T2 is a 0, what is that going to clue you in of which rule might be helpful? Okay, so let me, yeah, go ahead. Rule C, very good. Okay, so it basically can only boil down to the rule that mentions, T of something, right? And there are only 2 rules that mentions T of something, but only one, which is rule C, is going to say, hey, if we know, T of I plus 1, we can potentially use that to help us figure out what is, on the column I, right? Okay, so we'll use that. So now we look at rule C and we say, okay, we know 0 equals to the negative version of x1, y1, or the negative version of q1, t1. Let me just write it out so you guys can see exactly what I mean by that. Okay, so I'm going to continue my reasoning over here, and we'll say using rule C, we can now say 0 equals to negated x1, but we know what y1 is already, which is just a 1, or negated q1 and t1 is a 0. So we know that. Is that working okay so far? Does everybody understand why we can use rule C and make this little statement over here? We know it is false, okay? What is being false? The disjunction that has these 2 conjunctions as its operands. One conjunction is the negative version of xi and 1, and the other one is the negative version of qi and T1. Okay, how is that going to help me? How is that going to help me? Well, it's very restrictive because we know this is the result of the OR is false. So that automatically means both sides of the disjunction has to be false. So that's why I said it is restrictive, because it's saying this conjunction better give us a false answer. This conjunction better gives us a false answer. We'll deal with one at a time. Which one do you think I should start with? The one that has the most known values, right? So we're going to start with the left-hand side. I want it to be a 0. How can it be a 0? X1 has to be a 1. Very good. So this implies that X1 has to be a 1. Because if X1 was a 0, then we have 0, not 0, which is 1. 1 and 1 is a 1. If one side of the disjunction is 1, then it is conflicting with what we already know about T2. Okay? So that's helpful. And now what do? Knowing that X1 is a 1, how are we going to solve for Q1, T1? I mean, those are two independent variables, right? The answer is no, they are not. Because what do we know about Q1? Which rule?
A.
Rule A, right? So, okay, so we can now say, using rule A, we can now say that Q1 is what? Okay, let me just kind of make it very clear, because I want to make sure that we put all the known values into the space of the original question. So we know x1 is a 1, y1 is a 1, so what is q1 going to be? It has to be a 0. Okay, wow. All right. So now that we know q2 is a 0, and, whoops, sorry, what did I say? So now that we know q1 is a 0, let's put it here first. You go like, okay, what about T1? So this one has to be a 0. You go like, but we don't have any information to tell us anything about T1 because column 0 still has a whole bunch of question marks. We cannot possibly solve this. But wait, someone's going to help us. Okay? Because it doesn't have to depend on this side. It can also depend on this guy over here. In other words, T2 is still being helpful. Because we already said, based on what T2 is, x minus y cannot end up with a borrow. But what else is it also saying? Q1 minus T1 cannot end up with a borrow. Right? But we already know at this point, we know that Q1 is a 0. So 0 minus what cannot end up with a borrow? Cannot, exactly. You only got one choice here, okay? It has to be a 0. So now we're going to say, so once again, we use the implication symbol, and using C one more time, we can now say, T1 has to be a 0, and then you can say otherwise T2 equals to 1. That is why we lock it down. That's how we lock down the value of T1 being a 0. Okay, so we'll go ahead and fill that in and say this one has to be a 0. Well, we might as well finish the entire column, right? Because we already know the 4 values, on top. So what can we say about T1 at this point? First of all, which rule are we going to use? Look at the rules A, B, C, D, E. Which one says anything about D of I? There's only one, which is B. So now you say, okay, using rule B, we already know what is Q, we know what is T, so we are just looking at the exclusive OR between those two, and that tells us that D1 has to be a 0. And for all practical purposes, in terms of explaining the reasoning, I'm done. You guys go like, what? But we have the entire column 0 still unresolved. But look at the situation that we have here with respect to column 0. It is the same situation that we ended up with a little bit earlier, because we know T1 is a 0, the same way that we knew T2 was a 0. We also know that Y0 is a 1, with everything else being unknown. So that means if we just shift the indexes by 1, we can just basically reuse all the same reasoning. So if you just say that in your answer of, okay, I noticed this is the same situation that we had earlier, while T2 is a 0, T2 was a 0, Y1 is a 1, and everything being unknown, we end up with the same situation. It's just that the index is shifted by 1. You can now just say, okay, we're going to just apply the same reasoning and end up with the same values for all of these unknowns. So this is going to be a 1, and this one is going to, both of these are going to be zeros, and this one is going to be a 0, and so is this one. All right. So now we got all the bits known. Are there any questions about this entire process? So each step has several components, right? Yep, go ahead.
So is the only way to solve this by making the initial assumption that we did make?
I do not see other ways to do it. It's possible. Do you have any
Well, I was
proposed
just
method?
wondering, because I couldn't find another way without making the assumption either, but I didn't know if there was another way.
Okay. So what would be the other way?
No, I couldn't find one.
Oh, you couldn't. Okay.
Just,
Okay, I misheard. I thought you did. Because it is possible with some of the other questions. There are several ways to get started, because there are with the first question like this, with the least number of bits known, usually there's only one point to start. But with the other questions, you can probably start with multiple places and still end up with the same answer. It's kind of like playing the solitaire version of mahjong, when you need to undo the tiles.
I have a question.
Yep.
So how long would you think this should reasonably take us to do?
I think that's a very individual question. I cannot say how long each person is going to take. I took this long because I was explaining the entire time and just kind of go really slow. But if I were to just kind of sit down and just do it on a piece of paper without actually teaching, it wouldn't take too much time. It is about how you recognize which rule is applicable and how we can use it to narrow down the choices. So how many techniques have I used in this case to answer the question about to figure out the bits? Well, there are only a few, okay? The most tricky one is the way that we started here. It's like, well, we know the L flag is a 1, and using rule E, we know that these two have to be different. But we don't know how they're different, right? So do you guys have any questions back there? Nope? Okay. Because if you do, let me know, because I can address that question, and the whole class can benefit. So getting back, so that's how we split into two possibilities. That would be the trickiest part, is to basically say, okay, there are certain locations where you cannot use the derivation the forward way. When I said forward way, it means everything on the right-hand side are already known, and that's how we can figure out the left-hand side. That may not be the case. However, we can now say, well, there are only two ways to make L a 1, and it can be S being 1, O being 0, or it could be the other way around, which is S being 0 and O being a 1. That is one of the tricks that I used, is to explore both of these directions. With one of them being overflow is a 1 and the sign being a 0, it eventually led to a contradiction, which means it cannot be the way. And that eliminates. This is a process of elimination, of basically saying, okay, let's make certain assumptions, and we'll see how this plays out. In more colloquial terms, it is basically throwing something at the wall and see what sticks. In this case, it did not. But instead of throwing a lot of stuff to the wall, most of the time you only got two things. So you're throwing one at the wall, see if it sticks. No, okay, it has to be the other one. So that's when we resumed the other branch, and and basically applied all the other rules to try to figure out as much as we can about those uh, individual bits. I can tell you which two rules will give you the most information, or they can restrict the possibilities. The one rule is t of I plus 1, because that one, if t of I plus 1 is a 0, it's telling you a lot, okay? Because it's basically telling you um, not xiyi has to be a 0. It's also telling you not qiti has to be a 0. So that gives you a lot of information. The other one that also gives you a lot of information is rule D. Because rule D, especially if rule D ends up with a 1, if the overflow is a 1, that gives you plenty of information. Because it's telling you one of these two is going to be a 1. But for it to be a 1, you have to lock down 3 values. So that's also very restrictive. It gives you the ability to go like, okay, if I need to rule out possibilities, these two can really help. Yes, go ahead.
I think you mentioned that the rule C has additional restriction where both can't be one either, correct?
We already, yes, exactly.
That's what you mentioned. Yeah.
Well, they cannot both be ones because of the nature of Q of I. Yeah, they cannot be both ones because Q of I is the exclusive or between xi, yi, and that basically makes that if one side is a 1, the other side has to be a 0. That can be useful as well because you already know that one side is a 1, then you also know the other side has to be a 0. All right, so those are the techniques. You're combining what you have learned in class. In this case, it is encoded as the rules of A, B, C, D, E. That's what we learned in class. 2, the second ingredient is what we already know about this specific question. So it's a question specific known things up to this point. That's the second ingredient. The third ingredient is the techniques of reasoning, being basically splitting into two assumptions and trying to rule out one of them is one. It's the elimination of possibilities. You think of the possibilities and then you say, okay, is that possible? And then you derive it. If in the end you end up with a contradiction, you go like, okay, that cannot be the case. So you eliminate the possibilities, but if you have a binary case, then when you eliminate one, then whatever is left has to be the correct answer. This is a I'm trying to think of the term. This is the specialized version of what Sherlock Holmes said about reasoning. Once you eliminate all except for one possibilities, the one that is remaining, no matter how absurd it looks, has to be the one, right? Well, not quite using those words because I cannot remember the exact original phrasing, but that's the technique. And then the rest are really just using implications. These implications are truth table based. Okay, in other words, if I know, okay, I'll just give you an example here. If I already know that Q of I is a 1 and Y of I is a 0, how do I know X of I has to be a 1? It is using a truth table. Or you can just, you can either do it intuitively because you understand what is exclusive or you can use a truth table and basically say, okay, if the result is a 1 and the second one is also a 1, then the other one has to be a 0. The truth table will actually show you that. Do you guys want me to show you what I mean by that? Or are you guys going to be, yeah, I know what you mean? Nope. Okay, so you guys are good? All right. So that's question number 1. Question number 2 is going to be easier, and then question number 3 is the easiest. So I am going to switch. I'm going to skip those two for now and go to question number 4 because question number 4 has a different nature, and that's why I think it would be helpful to go to that one first. If we have enough time, or if you guys want to use the lab time to continue with question number 2 and 3, we can do that. Otherwise, I will skip to question number 4 because the nature is different. Wait, hold on a second. Question number 1 is not quite done because I've just done the part 1. There's a second part to it. So don't do what I just I was just about to do, skipping the second part of a question because that can be important too. All right, the second part is to show how to compute T3 using the following steps. Okay, so you got to follow the steps over here, and I'm going to do the same thing that I did earlier, which is to copy this portion to Zernal. So this way, I don't have to keep flipping and flopping around. All right, so you guys can see that. All right, so I'm going to paste it here. And I still need the table, so I'm going to have to, this is going to be interesting. I'm not sure whether this will work or not, but we'll give it a try. So I'm going to enclose this entire thing and see if I can copy and paste it, including the portion that I pasted earlier from the question. Yes, okay, that works out. Okay, I cannot complain then. All right. All right, so now we're trying to answer the second part of the question, which the first one is, what do we know about P? So this P here is the consolidated bit. It's a 3-bit wide thing, just like X and Y. So we need to know what is P1, P0, and P2 in order to figure out what is P. All right, so we'll go ahead and try to do this. Switch back to a pencil tool. So P is basically your P2, P1, P0. Okay, it's the concatenation of those three. So now the question is, how do we compute P2? And this is in the subtraction. All right, so how? Now, if you don't remember how to do it, it's okay. That's perfectly okay because I cannot remember a lot of stuff either. But what you do need to know is where can I find where how pi is defined and how gi is defined in the context of subtraction, because that's what we're doing. We're doing subtraction. So that would be the question. Do you guys know where to find this definition? If your answer is absolutely, because I wrote my own notes, I consolidated all the definitions in one place, and it's right there. Well, you're well prepared for this part of the question. If your answer is, well, I didn't quite make my own notes, but I remember when I read the modules, it's over there, okay? I remember that you specifically said, PI and GI are redefined because they're different for subtraction than it is for addition. Well, I will still say you get a gold star because you know where to find it. Because in the exam, it's open book and open notes. As long as you bring my modules and you know where to find the definition, it's not going to take you a whole lot of time. On the other hand, if your answer is, I have absolutely no idea where to find the definition of P in the context of binary subtraction, I would say, well, you're going to have a lot of studying ahead of you in order to be successful in this exam. All right, and all of that has nothing to do with the actual understanding of the material. This only has to do with going through the notes to know what you're supposed to know. Okay, all right, so I will answer the question. The answer is P of I is not X of I or Y of I. That is how P is defined in the context of subtraction. So in this case, X is 1, 1, 1. Y is 0, 1, 1. So now if I use the bitwise not operator, which is the tilde symbol, or C1 if you want, of 1, 1, 1, right, that's X. And then we have an OR Y, which is 0, 1, 1. So it ends up as 0, 0, 0, or 0, 1, 1. This is a bitwise OR operation. So now we end up with 0, 1, 1. So that would be P. Now we look at G. G is basically, okay, so when you look at this, you should probably in your head, if you equate this to concepts in Logisim, this is a splitter. Okay, on one side we have a 3-bit wide thing, on the other side we have 3 individual bits, and the splitter does exactly that. Okay, it converts individual bits, merge those into a multi-bit thing. That's what we are trying to do here. So it becomes G2, G1, G0, and we want to figure out what is G of I. G of I is the negation of X of I and Y of I. Instead of an or, it is and. So we kind of have the same thing here, the negation of 1, 1, 1, but this time it is ANDed with 0, 1, 1. And that's going to be 0, 0, 0, ANDed with 0, 1, 1. And this is a bitwise AND, so that means we end up with 0, 0, 0. Is that okay? So the key is not so much that you are going to repeat this process or to perfect the process that I just did. That will do you absolutely no good whatsoever. Okay? The key here is to understand where to find the definition and how to apply the definition. That is the most important part here. All right, so that answers the first and the second part of the question because now we know P is 0, 1, 1 in base 2, and then G is 0, 0, 0 in base 2. The third part is quite specific. There are several steps that you need to perform. The first one is to spell out the borrow look-ahead expression for T3. You go like, okay, so this has to do with binary subtraction. You go to the binary subtraction module, and you're not going to find how T3 is defined using P, G, and T0. Why not? Because we recognize the structure is exactly the same as K3. So you have to instead go to binary addition, figure out how K3 is expressed, and then just say, well, wherever K is, we'll just replace with T and we are all good. That part does depend on how much you understand about the material in class. Because in class, I specifically said that the T and the K are almost identical in terms of structure. The only difference is whether we negate X first when we try to figure out P or G. And I'm quite sure I said that, okay? And I can probably go back to the video and point to the exact time. See, I said it right at that moment. This is actually why I record my lectures, so I can actually do that. Anyhow, I have no idea, okay? I cannot remember, how, K3 is expressed, using the carry look-ahead mechanism. So I'm gonna look it up because I'm assuming that I can bring in whatever material that is printed already. So I'm gonna look it up. So to look that up, I'm gonna switch to the browser. So one thing that you might want to do is really just to print out all the modules just in case you need it. So we look for binary addition, carry look ahead, binary addition. Where is it? Right there. And we look up, but wait, there's more. And then K3 is defined down here. So I'm going to do a copy and paste. So we'll go ahead and screenshot, do a copy, and then paste it on the other side. Of course, you cannot do this in a paper-only exam, but it's also not really that much to copy over. Because once I copy, I still have to change the K to a T. So now I have to say T3 is G2 or P2G1 or P2P1G0 or P2P1P0. And of course, this is going to be T0 and not K0. Okay, so now I got how T3 is supposed to be computed using the borrow look-ahead mechanism. All right, so that addressed the first part of the question, which is I need to find the borrow look-ahead expression of T3. If you say, well, that looks like a lot of trouble, I don't like this method. Is there a different method? The answer is yes, but I'm not really sure that you like the second method either. The second method is to go back to the binary subtraction module. So let me go back to the browser first. And this time we'll go to the binary subtraction module, which is right here. And then we go all the way to the bottom, which is the borrow look-ahead generator thingy, which is this thing here. So you just go like, okay, I can deal with this. we're trying to figure out what T3 is. So we substitute n with 2, because then we end up with T3 on the left-hand side. And I'll just use this to generate the other parts of the expression. That works too. But I'm not really sure whether this is this is any better than the previous approach, which is really just copy and paste K3, change all the K to T's, we're done. Is that okay? So, but it is a method, okay? I'm not saying this is a better method. I'm simply saying this is an alternative to what I just did. I do want to point out the alternatives whenever I can. All right, so now that we have spelled it out, we just have to figure out what is G2. Well, all the G's turn out to be zeros, so that's easy to figure out, okay? And what is P2? P2 is a 0. G1 is a 0. What is P2? P2 is a 0. P1 is not a 0. P1 is actually a 1. And then all the G's are zeros. And then we have P2, P1, P0, and also T0. So T0 in this case is also a 0. So now we have 0 or 0 or 0 or 0, and we end up with a 0, which is consistent with what we figure out, using the other way about T3. But that will give you get you full credit, okay? You have to address the first part. The second part is to substitute each P or G bit with the actual value. I should have included T0 too, but I forgot to mention T0. Then perform the actual computation and get the value. So the computation is figuring out that 0 and 0 is a 0, 0 and 1 and 0 is also a 0, 0 and 1 and 1 and 0 is also a 0, and then 0 or 0 or 0 or 0 is a 0. That is how we show the quote-unquote computation. Are we good so far? Okay. So now I think we are now ready to move on to question number 4. Question number 4 in many ways is easier because it's going forward only. So I think it is going to take us less time, and we are going to be able to end the lecture on time. All right, so moving on to Q4. This is Q4. All right, so Q4 is, I try to be kind and explain what this is about so that people don't misunderstand that. Are we still dealing with base 2? Why do we have a 3 in a base 2 number? So I try to state it very clearly. This question is about addition in base 6. Okay, so we are out of subtraction land. We're now in addition land. And we are out of binary land. We're now in base 6 land. Okay. So x is given to you as 1, 2, 1 in base 6, and y is given to you as 2, 3, 2, 2, 3, 2, not 252. It is 2, 3, 2 because it's in base 6. It is not in base 10. So now the question asks, first, define RFG and CFG specifically for base 6 in the following space. Answering this part correctly is a condition for the next part to be scored, because if you don't answer this part, there's no way you can figure out the next part. Okay? So the question now is, how is RFG and CFG supposed to be defined for base 6? All right. So how do we answer that question? What is R of FG and what is C of FG? Yep.
R of FG is the function that says x plus y mod whatever base you're in. So this case would be 6. Right? So, or in this case, it's f and g. So f
yes.
plus g mod 6.
Yep. Cool. All right. What about the next one? What about C? Yep.
C would be the floor of f plus g divided by 6. Or it return 1 if f plus g is greater than 6. And 0.
Okay, there. Both ways will work. Okay, so if you say the floor of f plus g divided by what again?
6.
Okay, so so that's That's why I don't like, spoken language because it's ambiguous, because it's hard to specify. Are we taking the floor first and then do the division? Because you only said the floor of, but you didn't quite say, I know how it's supposed to be nested. Um, so what you meant is this.
Yes.
But that is not how it is defined in the notes. What is the alternative? How did I define it in the notes?
F plus G is greater than or equal to 6.
Yep. And specifically, question mark 1:0. Yep. Okay, very good. Okay, so that will get you some points already. It will also give you a pointer of how to proceed, right? All right. So to proceed, what do? We look at this whole thing. Okay, I'm giving you the entire structure of a multi-digit addition already. So you go like, oh, but we never really did something like that in class. I mean, we did not do a multi-digit addition in basics in class whatsoever. How am I supposed to answer this question? Well, what would be, how would you proceed? Instead of just saying, but Ted, you didn't teach us this. Yep.
Define Q, K, and S.
Exactly. So, okay, let me just kind of copy the question down. I'm just trying to figure out which ways. Okay, I'll just go ahead and do it by hand. 232. This is base 6. All right. Okay, so now we can switch over to Zerno. There we go. All right, so we got X, we got Y, we got Q, we got K this time because it's addition, and we got S over here. All right. So, Tech, are you really telling us that everything that we learned about the Q digits and the S digits and the K digits is still going to work here? Yes, that was kind of the point, right? Because I defined all of those things using base 10. And then I explained how we actually perform base 10 addition, which is something that you guys knew already before the class. And then I just specialized it into base 2 and say, hey, in base 2, we don't actually have to do the comparison. We don't actually have to do the mod or the floor because everything can be done using logical operators. That was kind of the point of that particular lecture. So now that we know this, Q of I is the same thing as R of xi, yi. Wow, that looks the same as before, except this time it is going to be xi plus yi, the whole thing, mod 6, and so on. You don't actually have to spell this out because I'm not asking. So instead of doing that, I'm just going to go figure out the digits. 1 plus 2 mod 6, 1 plus 2 is 3, 3 mod 6 is still 3. 2 plus 5 is 7, 7 mod 6 is a 1. 1 plus 2 is a 3, 3 mod 6 is still a 3. Woohoo! All the qubits are done. K of 1 is 1 plus 2 is greater than or equal to 6? Nope. Or 3 plus 0 is greater than 6? Nope. Nope and nope is nope. Okay, no means false. False and 0 are the same. All right, next one is 2 plus 7 is greater than or equal to 6 is true. 1 plus 0 is greater than or equal to 6 is false. We have true or false, which is true, so we put a 1 over here. And then 1 plus 2 is 3. 3 is greater than or equal to 6 is false. Or 3 plus 1 is 4. Is it greater than or equal to 6? No. So we have false or false again. So that means we have a false over here. And now we just have to do the R again. 3 plus 0 is a 3. 3 mod 6 is still a 3. 1 plus 0 is 1. 1 mod 6 is still a 1. 3 plus 1 is a 4. 4 mod 6 is still a 4. We're done. Now, does that make sense? Okay, well, there are two ways to verify. Okay, so if you're not running out of time, okay, you have time to go back to re-examine the questions. How do you double check your math is right? Well, one way to do it is to look at 121 as a base number, look at convert it to base 10, look at 23252 as a base 6 number, convert to base 10, and then look at 413 as a base 6 number, convert that to base 10. The base 10 addition should also add up with the same result. Okay, so that's one way to double check and verify. All right, so getting back to the question. So the other part of the question is, okay, I'm just going to point out using a pointer. What is the decimal representation of the value represented by the Q row and also the S row? Okay, so let's go back and take a look here. So the Q row is 313. 313 in base 6 is 3 times 1 plus 1 times 6 plus 3 times 36. And that is 3 plus 6 plus 108. And that would be 117, I think, in base 10. So if you're expressing, oh, you guys cannot see it. I'm sorry about that. All right, so this 3 tells us how many ones we have. This one tells us how many 6 to the power of 1, which is 6 we have. And this 3 is telling us how many 6 to the power of 2 that we have. That turns out to be 36. And that's why we have 1, 6, 36 as the multiplier to the digits at those specific positions. And now we just kind of have to add up all those things to become 117. And then the other question is about, I think, the K row, right? So the K row is easy. 0, 1, 0, 0 in base 6 is none of the 1s, none of the 6, which is 6 to the power of 1. We do have 1 of the 36 because that is 6 to the power of 2, corresponding to digit 2, which is a 1. And then we have none of the 6 to the power of 3, which is 36 times 6. 36 times 6 is 192. Okay. 186. So 36 is 18, 200, 216. Yes, my mental math sometimes is not as good as I thought it would be, but nonetheless, we know the answer is 36. So to answer this question, you do have to show the steps. You cannot just say this is 117. If you do not say this is 6 to the power of 0, 6 to the power of 1, 6 to the power of 2, instead you use 1, 6, and 36, I'm going to count it as okay. Okay. And then this step here is intermediate. If you jump from this step all the way to 117, that's fine too. But I do want to see something that relates to what each digit is representing. Are we good so far? So we are out of time. I can only demonstrate one question out of 3 out of the 2 categories because questions 1, 2, 3 are of the same category. Questions 4, 5, and 6 are also of the same category in the exam of spring 2022, which means your exam can be different. It can be very different, can be slightly different, can be different in a tricky way. So don't make any assumptions. That's what I'm trying to say. Do not make any assumptions. All right, so given that this was the exam in spring 22, how are you planning to prepare for the exam? Now, that answer depends on the person. Do you want to?
I don't know if you're asking a rhetorical question or not.
No, it is not rhetorical.
Like, same as, I guess, other people, just sit down and go through all the concepts and modules.
Yep. So when you said go through all the concepts in the modules, what do you mean by when you say go through? Because different people have a different understanding of what is going through, and I'll explain, the various versions of going through. One person can say, I will just kind of read the sentences. If I understand all the words of the sentence, I'm good. That would not be a good way, okay, to say, to go through the modules. And someone else can say, well, when I say that, when I go through the module, it means I look at everything, and I was able to boil everything down to how it connects to other concepts. Now that would be going through. It's going to take a while because you can go through something and go like, I'm not really sure about that term or what it means. It probably has been introduced earlier, but I'm not really sure what that was. Then you have to go back and say, okay, let me go back to where that term was actually introduced the first time and see if I understand that term. So that means you have to drill down, kind of like when you try to understand something from Wikipedia. Most of the time, Wikipedia has a link to something else, and you say, well, I kind of need to follow that link because I don't know what that word means. And then you land on a different page, and you do the same thing. You read along, go like, wait, that term I really don't understand what that is. That turns out to be a hyperlink too. Click on that one. So before you know it, you have like 16 tabs on your browser just for this little research. That is how we, quote unquote, go through the modules. So you can start in both directions. You can start with the latest one and see if you can fully understand everything. And if not, you go back to the earlier one. Or you can do the bottom-up approach, which is really just sequentially go through all the modules, in the order that they were introduced in class. But as you go through that, okay, as you quote unquote go through the modules, it is not going to take you much extra time to create a condensed version of what you learned. As you're creating a condensed version, I wouldn't do it on a piece of paper just yet. I would do it electronically. So this way, it gives you the option of repositioning things before you finalize and print it out. Because you might say, hey, at this point here, I found something that relates to that thing over there, and I want to put it over there instead of putting it down here. Instead of being sequential, doing it electronically means all you have to do is to go back to the earlier point of your condensed note, insert an item, right? Everything is pushed down a little bit. That's okay. And then until you say, okay, this is what I want to bring to the class, print it out. All right? Any other suggestions? Does anyone else want to share how you are planning to prepare for the exam? Because in this class, we are not competitive. I'm not just going to say, only the top 2 percentile of this class are going to get A's in this class. Everybody else is not going to get an A. That's not how I grade. That is not how I assign letter grades, which is something that I also should mention because somebody's going to panic at some point and go like, I'm failing the class. What am I going to do now? I'm going to have to mention that in just a little bit. So does anyone else want to contribute your way of quote unquote studying and getting ready for an exam? Yep.
Make a study sheet of this.
Exactly. The condensed version of the notes, that's your study sheet or study guide, however you want to say it. I got one student from my other class asking me to see if I can provide a study guide. And my first reaction to that question is, what is a study guide? Because all throughout the, let's see, I'm just doing the counting here, throughout the 9 years that I went through, quote unquote college / university / graduate school, I never encountered the term of study guide. Believe it or not. Then I had to look it up. And when I looked it up, it was supposed to be individual. It was supposed to be done by the student, not by the professor. So that was my reply to the students, like, oh, that's kind of on you. You're supposed to do that, not me. Yep.
I would just go through the exam and kind of go through, like, breaking down what the questions are asking.
Mm-hmm.
And that way, like, if you can get them ahead of time and you're reading through the questions, you are, like, highlighting and writing down, like, what exactly, because sometimes, like, the questions can be, like, fluffed up and you can get really overwhelmed and confused if you start overthinking everything. But if you look at it and you're very clear about this, find this, use
Mhm.
this, and doing it very like baby talk terms, like very like clear, so that when you get to it in the exam, you can kind of like refer back to like, okay, this, and this, and that way you're not giving yourself like anxiety or like taking yourself around in circles trying to like
If
figure
you
out.
if you ever have any doubt of what the question is asking or whether you're interpreting the questions correctly, you can always ask me during the exam. So I don't have a problem with clarifying what each question is asking. I don't have a question about answering whether the format of your answer is correct or not. So that's okay. You can always check with me and say, okay, is my understanding of what you're asking correct?
Yeah, that way you can just like, figure out what it's questioning, then you can just be like, okay, these formulas for this type of question this formula for like these types of questions, or like things that you'll see like that'll pop up and stuff.
Mm. Well, in terms of the equations, that is not something that you can quote unquote prepare ahead of time, other than going through the modules and finding all the definitions and all the equations. So you won't know which one to use until you see the question. I'm not sure whether I'm
No, I don't
addressing.
think you are. It's okay.
Okay. Yeah, but I cannot give you a sample of the question ahead of time for your specific exam because I don't have it. I mean, I literally do not have it until probably the day before the exam. Because I'm still kind of trying to think of how I can ask questions. So I do not know the format of the exam for this semester.
Well, I mean, just like going through the questions and like seeing what parts like you don't understand of like the formatting, that way we can get with you ahead of time. Or if there's like certain like um, equations that you don't really know and stuff in the questions, and that way you're just kind of reading ahead and be like, oh, we're using things like this, just keeping track of things that pop up, not necessarily associating them with like a certain question you're asking, but just like, oh, these are like things that are popping up repeatedly in the guide that you get, the practice exam that you gave us, just so that like for sure like these are going to be things that I'm going to be like seeing. You might as well have the like set aside like the
Right.
It's not just like going through like the notes, but like looking at your exam and seeing like which things are popping up repeatedly and stuff. Note and understanding like, okay, I have to make sure I understand these things well and what the question is asking.
Okay, I can tell you're supposed to understand everything well.
Yeah. Okay, never
But
mind.
other than that, I cannot tell you which part it has more likelihood to be asked in the exam, because the entire exam is still in the cloud, so to speak, not the actual network cloud, but in the cloud as in my mind, but it hasn't coalesced yet. Um, I would try my best to make the instructions clear, to indicate what you need to do and what the answer is supposed to be formatted. So I would try my best to be clear, especially because this is on paper kind of test. Most of the time, it's flexible enough that as long as I can see how you reason out the whole thing, it is okay, even if the format seems to be a little bit chaotic, as long as there are arrows to make all the connections. This is step 1, step 2, step 3, step 4, step 5. And as long as I understand that this is what I use from what we talk about in the class, and this is based on what we have already figured out so far, and this is an implication, and therefore we know this, okay? As long as that line of reasoning is clear to me, it is okay. I mean, I'm pretty flexible in terms of, how the answer is supposed to be formatted, as long as everything asked is addressed in the question. Anything else? Yep.
Will we be getting an answer sheet for the exam or?
Yeah, I can give you the answer sheet, which may not be in the format that you expect, because I have a program to automatically generate the answer, so it's going to be pretty robotic. Yep. Mm-hmm.
Do you have any time to go over one more question?
Well, since we are in the lab time and I don't really have a lab prepared for today, we can continue.
Okay.
So which one do you want?
Number 2.
Number 2?
Yeah.
Okay, let's work on number 2. All right. Any other requests, comments, questions? Yep.
Are you taking roll today?
I am not taking roll today, because I think missing today's class is enough by itself, enough of a consequence.
Quick question, Professor.
Yep.
The scope of the exam, is it binary subtraction and everything that you need to know to make that work as well?
So the scope of the exam is everything up to and including binary comparison. And that's why we have the overflow and the L flag, because we only talked about that in the binary comparison module.
Right.
And also don't forget about the labs. The labs are useful as well. Okay, so make sure that you kind of go through all the labs too, to make sure that you can, understand the association between the material in the lecture and the lab. All right, so we are looking at question number 2. Let's try to figure that out. how detailed do you want me to go through the reasoning? Do you want me to use the same approach as question number 1, or do you want it to be abridged?
I want to see how you would like a student to put the reasoning for that question.
Oh, okay. Okay. So I can tell you how I would answer that. How about that? Because as I said, it can be very flexible. Okay, as long as it is clear to me, how what the chain of reasoning looks like, it's still okay. So so I'm gonna cheat a little bit here because I'm gonna reuse the same 5 rules from earlier. I think those are the 5 that we used in this class. All right, so we could go like. Oops. Wrong place. There we go. All right. So obviously you guys cannot see it because I have not shown you. So there we go. All right. So this is the second question, or question number 2, and it does give you more information. You have more bits to start with. So let me just look at this and see which one is easy. Okay, there are a few. One is really easy to work with. I think this one is easy. T0 is easy to work out. And then the next one that's really easy to work out is going to be Q2. Does that work? Okay, so this time we do have 2 starting points. Okay, 2 ways to start the whole thing. All right, so let's go ahead and work on this. All right, so the way I would write my answer, let me switch back to a pencil tool. So the way I would write my answer, if I have time, is to basically also restate what is known at this point. So I'm going to say D2 is a 0, and T2 is a 1, and the rule that I want to quote, which in this case is going to be rule B, implies that Q2 is a 1. Yep, go ahead.
Could we automatically just say T0 is 0? Because it was already implied
Nope.
earlier?
No, T0 is not known to be 0. It is an unknown. In some of the questions, it is a 1.
Really?
Yeah. Because do you remember the circuit to do the carry look ahead adder? Do you remember that circuit?
I do.
One of the input pins is K0.
Oh.
So K0 is an actual input. It can be a 1 or a 0.
Right, okay.
So T0 is the equivalence of K0, but in the subtraction.
Okay.
So it is unknown. It can be unknown. It can be known as a 1, can also be known as a 0.
Okay, so all those problems that we did earlier, we've always implied that it was 0?
Right.
But in this case, it's still a question mark, just like.
It is a question mark, yes. Okay. Yep, definitely. All right, so that gave us a 1. And then based on that 1, we can now use a T2 to help us figure out what is X and Y. Okay, so we'll go ahead and say T3 is a 0. And we'll quote the right rule, which is rule C in this case. And I would just say that you can simplify this and say, X2 is a 1 and Y2 is a 0. Okay, so we can just kind of shortcut the whole thing and you'll come to the conclusion, but you do have to tell me why you think this is leading you to believe that that is the case. Okay, there's one more thing that locks it down. It has to do with Q 2 is a 1. There we go. So knowing that Q2 is a 1, which is this one here, knowing that T3 is a 0, that leaves us no choice but to say that X2 has to be a 1 and Y2 has to be a 0. Is that okay? Yep. All right. In fact, I'm using two rules. I'm not just using rule C. I'm also applying rule A. So that would be one way to represent, the reasoning, is to quote, what we have, what is known at this point, combined with what equations is coming to what kind of conclusion. Okay. All right. So now we have figured out this is 1. This has to be a 0. All right. So what do we do next? Well, what we can do next is going to be, let's work with digit 1. Okay. Well, we can also do something like really kind of silly. We can say, we know what is D0. D0 is a 0. We know what is Q0. Q0 is a 1. And using rule B, we know that T0 has to be a 1 as well. So right there, so T0 is a 1 in this case. So this is a 1. All right, but that doesn't give us a lot of options about x and y because we don't know anything about the borrow bit. So we can't really come to any conclusion about x and y. The only thing we can say is x0 and y0, they're different because q0 is a 1. But other than that, I don't have enough information. So I'm going to work out the other end, which is, this is useful. Combined with this, I think we can figure out the rest. Okay? All right. So I am going to say, but in the class, I'm going to go step by step to kind of give you, an idea of how that works. So we'll say, we know D1 is a 0. That is given to you. Okay? It's not something that we worked out. We also know that T2 is a 1. Okay? All right. So what does that imply? This by itself is telling us that Q1 has to equal to T1. Okay, let's think about this one more time. D1 is a 0, which is the result of the exclusive OR between Q1 and T1. If that is a 0, we know that Q1 has to be the same as T1. Now, are they both 1s or are they both 0s? I cannot tell right now, okay? It can be either one. Okay, but we know they're the same. So knowing these two are the same is telling us that the negation of Q1 T1 has to be a 0. Does that make sense? Because if they are the same, and I negate one of them and end it with the other one, then one of them is going to be false. One side of the conjunction has to be false. So that means the whole thing is going to be false, right? But if you recognize what is not Q1 T1, well, that is really the same thing as B of Q1 T1. That's how B is defined in binary subtraction. We have a borrow. But in this case, we're guaranteed, that Q minus T is not going to end up with a borrow. But it is a problem. Well, okay, I shouldn't say it's a problem. It is actually a good thing because now we know exactly what x and y need to be, right? Okay, so let me just do one more implication. So this whole thing is implying that B of x1, y1 has to be a 1. How do we know that? Which rule did I use to make this particular implication?
Was it rule C?
Yep, it is indeed rule C. Because rule C is basically saying we end up with a 1 with T2 if and only if at least one of these two borrows is a 1. But we have already made the conclusion that the B of Q1 T1 cannot be a 1 because they have to be the same. Q1 T1, they have to be exactly the same. They can be both 0s, they can be both 1s. But either way, it's not going to end up with a 1 for the entire B function. So that means if I know that T of 2 is a 1, the only one that can contribute now is the borrow of xi minus yi, or x1 minus y1. Is that okay? And the only one for a borrow to be a 1 is 0 minus 1 in a binary subtraction. So in a certain way, binary subtraction gives us more information than binary addition, because binary addition means, because it's commutative, 1 plus 0 is a 1, 0 plus 1 is also a 1. It's not going to give us as much information. In this case, it gives us a little bit more information. I shouldn't say that, but because carry also locks down both bits if I know it's a 1. But in this case, knowing this is a 1 implies x1 is a 0 and y1 is a 1. Is that okay? And that is using, yeah, this one doesn't use any particular rule. I mean, you can re-quote rule C, because the way I spelled out rule C is also including how B expands to the binary version of the same function. Okay, so now we know this is a 0, we know this is a 1. That really helps us, because now that we know what is 0, what x1 is and what y1 is, it tells us using rule A that q1 is going to be a 1, right? Because now that we know this is a 0, this is a 1, the exclusive or between those two has to be a 1. So that way we figure out this has to be a 1. The rest is pretty easy, okay? Because now we can also say that implies using rule B. Why rule B? Because we know what is D2, excuse me, we know what is D1, we know what is Q1. Well, that kind of helps to lock down what is T1. So what is T1 supposed to be? We actually knew from another earlier discussion that T1 and Q1, they have to be the same, right? So if Q1 is a 1, T1 also has to be a 1. Are we good so far? All right, so using B or some earlier rule, either way is fine. You basically figure out T1 is a 1. Okay.
And now you just use rule A to lock down x0, y0.
Not just A, because A gives you two possible scenarios. Because rule A alone can only say that, well, x and y are different. So you can have a 0 minus 1. You can also have a 1 minus a 0. So you have to combine that with rule C,
Yeah.
because now you know what is T1. So you know, oh, okay, it's supposed to give me a borrow. We know that QT is not giving me a borrow. So the borrow has to come from xy, which means x has to be a 0, y has to be a 1. So now, knowing what is T1, by combining rule A and also rule C, we can now say that x0 is a 0 and y0 has to be a 1. So now we put a 0 here, we'll put a 1 here, and I'm just checking the math here. Yep, that looks right. Yep.
And we know now, and we figured out earlier that O is 1. So.
Oh, right, we have to figure out two. Okay,
Well,
good
O is
job.
1, right?
I almost neglected, those two flags here. Yes, so now that every other bit is already figured out, O is easy to figure out. So, yes, so good job. I forgot about those two bits entirely. So O is, in this case, it's 1, 0, 0. So it is 1 and not 0 and not 0, or not 1 and 0 and 0. This side becomes a 1, so overflow is a 1. Yep,
Right.
Go ahead.
And then you figure out L with E, right?
Right.
So you're okay with these labels? Like if we typed out all the definitions ahead of time and labeled them?
Absolutely. Yep.
Okay.
In fact, well, yes.
It might be applicable because we don't know how the
You can just refer back to, if you, because I don't want you guys to spend a lot of time to kind of just copy and paste between the questions. You can just say, refer to Q, answer the answer of Q1 for the labels. That's good.
Okay.
As long as I know where to find how you define the labels,
Yeah.
it's going to be okay.
Or maybe even if we just defined it at the top, like a global variable of definitions, and just like refer to them throughout each answer.
That works too.
Okay.
Yep, that works too. As long as I can, because I'm grading it. It's not automatically graded.
Right.
So as long as I can understand what you're trying to tell me, and I find what I need to know that you understand the material, that you are deriving it correctly, then it's going to be okay. So now we have, this is basically D2 exclusive or with uppercase O. D2 is just given to you, that's a 0. And big O, I mean uppercase O is a 1, so that is a 1. So the L is a 1 as well. All right. So does that kind of address the question? Because I think Anthony asked about question number 2.
You did.
Yeah, so the other part is the same, so I'm not going to go through the P and the G, because that part is really just kind of plugging in, what is X and what is Y, figure out all the P bits, figure out all the G bits, and so on. Yep, so I'm not going to spend time to explain that portion because it's plug and play. All right, any other questions? So how do you know you're making the connections? Because understanding is about the connections. I cannot see whether you're understanding the concepts because I don't know how to mind map. I'm not Vulcan, not even half or quarter or an eighth. So I cannot do a mind melt with you, your mind to my mind, your thoughts to my thoughts, and see, okay, I can see you understand all this stuff now. I cannot do that, okay? So the only way I can get some evidence that you're understanding the material is to see whether you can apply the knowledge combined with what the question itself is giving you and make the connections. I can see how these given things combined with these knowledge that I have gained in the class can be applied to resolve what these bits are supposed to be in this in question number 1, 2, and 3. So that is why the questions are created the way that they are. So how do you practice? Okay, so here's another question. Somebody asked that question in another class. Is how do you practice? Because I only gave you like 3, right? But how do you do more practice? Yep.
Just come up with examples for yourself.
You can try to do that, but if you try to do something like that on your own, you can potentially end up with places where the question marks can be either 1 or 0. Because, I have a program to generate these questions where it is guaranteed that each question mark has to be a 1 or 0, cannot be both, cannot be either. So when you do this, so I have a way, okay? So I can recommend, I shouldn't say recommend, I can give you an idea, okay? Whether you want to use it or not is up to you. So let me get a new page. Get a random number generator, okay? Your calculator can usually do that. If you don't have a calculator that can do that, there are probably web pages that can give you random numbers between a certain range. So get a random number generator. So you want to give yourself a 3-digit number. So one way to do it is to get a value between 0 and 7. Now 0 is not really that useful, but nonetheless, just go ahead and do that. So let's just say that I have 1 and 5. Okay, I run the random generator twice. The first time I got a 1, second time I got a 5. So what you do is the first thing you can do is to convert both of these to base 2 numbers. Okay, so now we have 0, 0, 1 and 1, 0, 1 in base 2. So now there are several things you can do. You can say 1, 0, 1, 0, 0, 1 in this orientation. You can also flip it so that you have 0, 0, 1, 1, 0, 1 in the other configuration. Okay, so you can say addition. Addition is not too much fun because it's commutative, so it doesn't matter which way you do it. Oh, this is supposed to be subtraction here. That is supposed to be subtraction. Okay, one more. Okay, this is supposed to be subtraction. This is supposed to be addition. And this is supposed to be subtraction. So now you have just given you a problem to go forward, right? Yeah, because using the 5 rules, A, B, C, D, E, you should be able to figure out, how to fill up the five rows. This is X, this is Y. So when you have an addition, you have Q, K, S. When you have a subtraction, you have X, Y, Q, T, D. Okay, so going forward is one way. Okay, so let's just say that I take one of these guys and go forward with it. So let me just pick the one that is probably the most kind of challenging one, which is this one. So 1 minus 1 is a 0, and let's just say that there's a 1 here. Once again, you can determine whether you have a 1 here or 0 here using a random number generator. Okay, so I'm just using a random generator, and it so happens to say T0 is a 1. Okay, so now we have a 1 here with a borrow. 0 minus 0 is a 0. 0 minus 1 is a 1. 0 minus 1 is a 1. And this 0 minus 1 ends up with a borrow here too. So we have a 0 and a borrow down here. Okay, so you look at this, the first thing you need to do is to say, but how do I know I did this correctly, right? That would be the first thing. So the way you answer that question is to say, well, we know what 1, 0, 0, 1 is supposed to represent. That's just 1. In fact, we know the other one is 5 because that's how we got 1, 0, 1 to begin with. So 1 minus 5 normally would end up with a value of negative 4, which is not what we have. But that's okay, because we'll see whether we get back to negative 4. So now we end up with a 3. So the actual answer is a 3, but we also have a borrow of 1. So we are actually subtracting 1 more to be negative 5. The extra negative 1 here has to do with T0 itself is a 1. Okay, so T0 is just one more thing that we are subtracting. If T0 is a 0, we don't have anything extra to subtract from your x. If T0 is a 1, then we have to subtract 1 from the difference of 1 minus 5 in this case. All right, so now we're supposed to end up with a negative 5. Then you look at the 3 and go like, I'm not really sure how 3 can be a negative 5. But we are looking at this borrow bit here. T3 is a 1, is telling us that we owe something, right? So what are we owing? We're owing 2 to the power of 3 because that is the position corresponding to T3. This one is saying that we owe 1. This one is saying that we owe 2. This is saying that we owe 4. This is saying that we owe 8. So if you have $3 in your pocket, but you actually owe the bank $8, what is your net worth? Negative 5. So I have just verified that my binary subtraction is working. So now that you have this part working, what are we going to do? So we want to figure out the L flag. We want to figure out the O flag. So in this case, the O flag is a 0 because the shortcut to figure out the O flag is to ask, is the most significant bit of x different from the most significant bit of y and different from this most significant bit of the difference? And in this case, it's different from one, but not the other one. So that's how we know it is not overflowing. Okay, so if it's not overflowing, and we look at the sign flag is a 0 as well because that is D2. So now we have 0 exclusive or with 0, which is a 0. So now we have figured out all the bits. So what do you do with this? Now you play the other game because when I give you the problem in questions 1, 2, and 3, it is analogous to Sudoku, right? You know the rules of the calculation, but you have a lot of holes, a lot of unknowns. You try to figure out what the unknowns are. So now we're doing the opposite, which is how do you call that game where you have a lot of sticks and people are supposed to remove the sticks? The last one to remove a stick and then the whole thing collapses, loses the game. What is that? Hmm? Sorry?
Jenga?
Jenga. Okay. So now you're playing Jenga. Basically, you're asking, can I remove one bit here and still be able to figure out all the bits that have been erased up to this point? So it's best to play with somebody else, right? So now you look at this whole thing, and then you say, well, if I just remove, okay, I'm just randomly picking something to remove here. If I just remove this bit here, would it be okay? Can I still be able to figure out what that bit is supposed to be? The answer is, yeah, that's easy peasy. Why? Because we know what is the D, we know what is the T, So the Q is easy to figure out, not a problem, right? So now we look at this and go like, okay, what other bit can I remove and still be able to figure out everything? I mean, initially there are a lot of choices, but then at some point you go like, oh, if I take this out, I can't figure out the rest anymore because something is going to be ambiguous. I have lost enough constraints that I can no longer lock the zeros and ones of all the bit positions. So you say, okay, next thing I'm going to remove is the L flag. Oops. So I'm erasing the L flag here and ask, well, is that going to be okay? The answer is, yeah, sure. I mean, we can still figure out the L flag because we know we're still given the overflow flag. We're still given the sign flag over here. Not a problem. Does that make sense? So you basically go through this whole process until you have removed all the bits that you can possibly remove. So now you say, okay, can we remove this bit here and still be able to go back and figure out what that is supposed to be? That's easy. Because we know what is Q already, we know what is Y already, X is easy. Okay. So you keep doing this until you get to the point of if I remove any more bits, okay, I may not be able to reconstitute all the missing spots already that's already gone. Does that make sense? So that would be a quote unquote a game that you can play potentially with somebody else. You know, if you have a study buddy, you can do this with your study buddy and go like, okay, I remove this bit. It's your turn to remove a bit. Is that making any sense? Because this is forcing you to reapply the rules that we have learned and try to figure out, okay, have we just lost too many bits and we can't go back to figure out what the entire thing was supposed to be? So between the Sudoku approach and the Jenga approach, that's how I would kind of that's one way to study for this class. Kind of make it a little bit fun and a little bit hands-on, and are we good? Now you can also do this approach with base 6 subtraction and see how many digits you can remove until you are no longer able to figure out what the other digits are supposed to be. Because what the basics question is really asking is, do you really understand the rules of multi-digit subtraction? The dependency between the digits and so on. So that's a few things that we can do. You can also kind of review the circuitry for the carry look ahead adder. Okay, so when you go back and look at the carry look ahead adder, you should be able to equate the circuit that you created, or if you use my version, it's even more important. You have to be able to equate the circuit to the equation in the module. Like K3 is blah, 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 blah. And then you look at the circuit of K3 in that particular lab, you go like, okay, are they really doing the same thing? You should be able to convince yourself that, yep, I can see how this is an expression, this is how we write it out, but this is the circuit. If we need to build a computer using transistors, using logic gates, this is how we build a circuit to do exactly the same thing as what that equation is trying to say. All right? You can also do something like finish this whole thing. Now, in this case, let me kind of undo the blanking out so I can reconstitute the whole thing. So in this particular case, what is P? This is a subtraction, so P is going to be 1, 1, 0, or 1, 0, 1, which turns out to be 1, 1, 1. G, in this case, is 1, 1, 0, and 1, 0, 1, which turns out to be 1, 0, 0. Okay. So you look at P and G. So if you are given P and G, can you go back to try to figure out what the X and Y are supposed to be? If not, what is the limiting factor? So those are the kind of puzzles you can do, right? So we know what is X. X is 0, 0, 1. We know what is y. Y is 1, 0, 1. So now between these bits, you play Jenga again. You play Jenga again and say, I'm going to take out one of these bits here. Can I go back and figure out what that is? Okay. In other words, for example, if I take this out, but all the other bits are still known, that is not a problem because I can always construct the P and the G bits as long as the X and Y are given to me. So that's no fun, right? All right, if that is no fun, let's reverse that. And this time, instead, you are taking out a bit over here. So the question now is, knowing that P is 111, G is 100, X is 001, can you deduce, no, this is not X, sorry, I take it back. No, it is, okay. So knowing that X is 001, Y is 1 something 1, can I go back and backfill this space here? What do you think? The answer is yes, you can. Okay, the reason why you can do that is because you know how P is defined, and if you already know what X is, so actually, and you know what G is. So the key here is not P, because P is going to say, you know, there are two ways for this bit to be a 1, because the negation of Y, the negation of X, excuse me, X has to be 0, so the negation is a 1. That's one way to get a 1 over here. The other one is Y has a 1 in the same position. But if X is already known to have a 0 at this position, that's guaranteeing a 1 here already, regardless of what Y has in the same position. So P is useless when it comes down to knowing what this position is supposed to be. But G is helpful because G says, I'm seeing a 0 here. But from X, we already know that one side of the conjunction is a 1, but somehow the end of the conjunction is a 0. So that means, oh, okay, so that means this has to be a 0. It cannot be a 1. Because otherwise, G of 1 would end up as a 1. So now you have to say, okay, so we can actually take out Y1 and still be able to figure out what it's supposed to be as long as I know the P1, G1, and X1. So you basically want to play this kind of game and see whether you can go backwards, okay? Instead of using X, Y to figure out P and G, you would try to go backwards and say, if I know the P and the G and missing something in X and Y, can I still go back and figure out what I'm missing? Is that okay? Because it's the same kind of thought process that we went through earlier in class. It's just that the rules have changed a little bit in this case. This also is easier because we don't have any ti plus 1 equals to things from the previous column. All of these are from the same column. So, that makes it a little bit less challenging. All right, anything else? All right, well, if you guys don't have any questions for now, we can end the lab also. You guys can go. But what I would do, now today is Wednesday. The exam is next Wednesday starting at 10:30. So that means we have one lecture in between. I always schedule the going over the previous semester's exam and the actual exam. I always schedule a class in between so that you guys can bring your questions back. And you guys have a long weekend, right? Because we are meeting on Monday, and today is Wednesday, so that means you have quite a few days to go over the material. If you have any questions as you go over the material, I can address those questions on Monday. All right? Oh, one more thing. I'm sorry, that I have to pull another Columbo here. One more thing, sir. How I give you the letter grade A, B, C, D, F. I need to talk about this because otherwise people start to panic. The threshold from a F to a D is 12.5%. This threshold is 37.5%. This threshold is 62.5%. This threshold is 87.5%. In other words, I don't want someone with a final score of 64% to come to me and say, I'm failing the class. What am I going to do now? No, you're getting a B out of this class. What are you complaining about? I do want to emphasize this because I get people who are panicking all the time. When they look at the score, go like, I'm failing the class. No, you're not. Not yet.
Hi, Professor. I'll see you.
All right. All right, I'll upload the video as soon as I can.